Hello everyone, good evening and welcome to my channel Aptitude Club. So today's session is going to be on Chinese Remainder Theorem. I had started the remainder series a few weeks back and we have already done several sessions on remainders. So this is the next topic that is Chinese Remainder Theorem. We have discussed basic remainder theorem, Fermat's theorem, Wilson's theorem, Euler's theorem, remainders on continuous digits and how to solve questions on them. So we have discussed these like chapters in the remainders area. Today's topic is specifically on Chinese remainder theorem. Very important to understand Chinese remainder theorem because this will enable you to solve almost every question on remainders, because the theorems we have discussed previously maybe were a little specific related to their design, but Chinese remainder theorem is again a very broad application. So if like nothing is like applied in any question, you can use this. So I'll take you into two aspects of Chinese remainder theorem because there are two ways of looking at it. So I'll try and explain both the ways using a few examples so that you get a clarity of what Chinese remainder theorem is. Now, those of you who would be watching this for the first time, or if you are watching the videos of this channel for the first time, do subscribe to the Aptitude Club channel. I post videos regularly, from the topics quantitative aptitude and LRDI, and this will help you immensely in your CAT preparation journey. So if you found or if you find these videos useful and you like the way I am solving questions or explaining the concepts, do like and subscribe the channel Aptitude Club. And if you have missed the previous videos, I'll pin them in the I section of this video, and I'll also share the link of the total playlist of remainders that I have already completed in the description of the video, so do check it out. So without further delay, let us begin. So let's start with a question. Okay, when and where we should think of applying Chinese remainder theorem. Now, when we see this question, the divisor here is 77 and the dividend here is 3 to the power 52. Now, this is a composite divisor, composite number. Now, we had discussed that whenever the divisor is a composite number, in general, we can apply Euler's theorem. And how do you apply Euler's theorem? Let us say I am taking this number n. First, I need to find the Euler's totient number or totient function phi of n. Okay, do watch the Euler's theorem so you can relate to what I am saying. This I have already done a detailed video on that. So first, whenever you have any number, find its Euler's totient function, number of natural numbers that are less than and co-prime to 77. So how do you factorize this? 7 to the power 1 into 11 to the power 1. So I can write phi of 77 is 77 whole into 1 minus 1 by 7 whole into 1 minus 1 by 11. This is a direct formula Euler's totient function ka. So into 6 by 11 into 10 by this. So we get 60. Once you get 60, as per Euler's totient method, or Euler's theorem, we can deduce that 3 to the power 60 when divided by 77, the remainder is 1. This is directly using the theorem. 3 to the power 60 divided by 77, the remainder would have been 1. Anything more than 60, we can break it and solve. But anything less than 60, that's where the limitation of Euler's method comes into play. Because if the power is lesser than 60, why do we use these theorems? To reduce the power. We'll be given bigger numbers. We will use these theorems and lessen the power so that it will be convenient for us to solve. But what if the powers are already reduced, or we cannot use the theorem to reduce it further? That kind of a situation, we have to use Chinese remainder theorem. Okay, so if I write the limitation, if phi of n is greater than the power of the dividend, that is where you use Chinese remainder theorem, or else you can easily solve this using Euler's theorem. ऐसा नहीं कि चाइनीज रिमाइंडर थ्योरम अगर लेसर देन है वहां पे भी यूज नहीं कर सकते. वी कैन यूज चाइनीज रिमाइंडर थ्योरम एनीवेज. ओके, डजंट मैटर क्या पावर है क्या नहीं है. चाइनीज रिमाइंडर थ्योरम कैन ऑलवेज बी अप्लाइड, बट यूलर्स थ्योरम कैन ओनली बी अप्लाइड इफ phi n इज ग्रेटर देन पावर ऑफ द डिविडेंड. इफ इट इज ऑलरेडी लेस तो नहीं कर सकते. जैसे यहाँ पे phi n आ रहा है 60, सो इफ द पावर इज ग्रेटर देन 60, I'll go for Euler's. If it is less than 60, I'll go for Chinese. इनफैक्ट चाइनीज तुम कोई भी पावर के लिए यूज कर सकते हो. So then you might think, if that is the case, why not only use Chinese? Why only why to learn Euler's? Because it has a limitation. Now the first way of applying Chinese remainder theorem is not very convenient. Okay, it's a little lengthy compared to Euler's. So that is why we will not use Chinese until and unless absolutely necessary. Okay, the first way of looking at Chinese remainder theorem, because थोड़े 5 steps है उसको करना है. But once you practice a few questions, you'll get used to it. But the point is, if it is not necessary to apply, why will we apply? Maybe we can use some other theorem and easily get our answer. Same equation को क्यों 5 step में solve करके lengthy करें? That is the reason I'm teaching you all the theorems. Binomial theorem भी पढ़े थे, Euler's भी पढ़े थे. तो if you know all the theorems, then you will be at a stage to decide, okay, for this particular question I can apply this. That question can be thought upon this way. This is how I can reduce the power of this question, and so on, because you know the entire aspect of remainders, all the possible ways of looking at it, and then you can optimize in your mind which method I should go for to get the answer of this question easily. Okay, but I hope all of you understand what is the limitation, because once I get that phi of n is 60, whereas the power is already reduced. मान लो पावर ऐसा होता 64 या 70 या 75 greater than 60, I could have gone for Euler's, but power already reduced. Okay, 52, 40, 36. These are not even small numbers. 3 to the power 36 भी लेंगे काफी बड़ा number है. But I cannot use Euler's here, even if the purpose of Euler's is to reduce the dividend. तो इस टाइप के क्वेश्चन को कैसे सॉल्व करते हैं, and how we should try and use Chinese. तो that is what is the purpose of the video. Let's go forward and पहले समझ लेते हैं Chinese remainder theorem में करना क्या है. So for an example, just to elaborate you a little more, suppose the question would have been like this: remainder of 3 to the power 65 divided by 77. Suppose it would have been like this. तो मैं क्या करता, इसको ऐसे ब्रेक करता. This is remainder of 3 to the power 60 into 3 to the power 5 divided by 77, and then you can break it in this way. It is 3 to the power 60 divided by 77 into remainder of 3 to the power 5 divided by 77. And here the remainder of course is 1. यहाँ पे रिमाइंडर तो 1 है, एंड तुम्हें इसका रिमाइंडर निकालना है, तो यू विल ब्रेक इट फर्दर. तो 3 to the power 5 I'll write it as 3 to the power 4 into 3 to the power 1 divided by 77. 3 to the power 4 divided by 77. How much is 3 to the power 4? It is 81. 81 divided by 77, remainder is 4, and 3 divided by 77, remainder is 3. So 4 into 3 आ गया 12. Remainder of a product is product of remainders. First theorem, basic remainder theorem. जो लोग ये पहली बार देख रहे होंगे ना, sincerely I'll advise you, just watch it from the beginning. The entire remainders का जो playlist है, just watch it from the beginning, and I can assure you that any question on remainders will be able to solve within 30 seconds. But you need to read it in a structured way. अगर बीच में हम देखेंगे कोई वीडियो, तो do watch the previous videos to get a complete idea, because it's a continuation series. What I have done is numbers को I'll break it into parts and then I'll discuss. जैसे remainders एक part हो गया, factor theory एक part हो गया, and so on. तो यहाँ पे देखो इजीली आंसर आ गया. Why? Because the power here is greater than phi n. Because phi n यहाँ पे अपना 60 था, तो पावर जब greater than phi n है, 65 या 75 so on, you can solve it in this way. But like this question where the power is less, तब कैसे solve करें? Euler's can't be used in that case. I hope you got the logic that क्यों Chinese remainder theorem use होता है. So these are basically the steps. Okay, suppose you have to divide any number m by n. कोई भी number से divide कर रहा है. So in general, for any particular division, we can use Chinese remainder theorem to calculate the remainder. So remainder of m divided by n. तो m यहाँ पे अपना dividend हो गया, जिसको तुम divide कर रहे हो, and n is your divisor, जिससे divide कर रहे हो. So if m is the dividend and n is the divisor, these are the steps. First step, you break n as a into b, where a and b are co-prime to each other. Co-prime का मतलब HCF of a and b are 1, मतलब is 1. Meaning of co-prime is there is nothing in common between those two numbers. You have to break it in such a way that their HCF is 1. Then step 2, divide this m, dividend को, rather than dividing it with n, you divide it with a, and let us say the remainder is r1. कुछ तो एक remainder आएगा उसका, divided by a. Similarly, divide the same dividend m with b. मैंने n को a and b में break किया, तो तुम्हारा जो डिविडेंड है उसको इंडिविजुअली पहले ए से डिवाइड करो, देन फिर बी से डिवाइड करो, तो विल गेट रिमाइंडर्स R1 and R2. Then what you do is you have to design an equation ax plus by is equal to 1. You already know the values of a and b. By breaking n, you'll have to figure out x and y. यहाँ पे x and y को figure out करना है such that they are integers and ax plus by is equal to 1. ये condition meet होना चाहिए. I'll solve and explain how. Just पहले steps देख लो. And then the final answer, remainder of r, मतलब r when divided by n, m divided by n, जो final remainder है. This is what we are trying to calculate. तो n की जगह m divided by a into b, so it is a r2x plus b r1y. This is how you calculate. थोड़ा steps है यहाँ पे, but you will absolutely get the answer without any worries. But it's a little lengthy related to the other theorems, but with practice you will eventually get the speed, don't worry. And if you're comfortable enough, it will not take you more than a minute. But let me like explain you what's the logic behind doing this. पहले क्या होता था, when the number n, ये जो नंबर n है, ये जब बड़ा नंबर होता था, ठीक है, फॉर एन एग्जाम्पल, ये जब बड़ा नंबर होता था, n को मैंने अगर 77 लिया, तो 5 of 77 आ रहा है 60 एंड माई पावर वॉज 52, तो ये ऑलरेडी उससे बड़ा है. बट अगर मैं ये 77 को ब्रेक कर लिया 7 into 11, तो ईच नंबर का 5 of 7 देखो कम हो गया. 5 of 7 is 6 and 5 of 11 is 10. So now my division becomes more convenient because I reduce the phi n value. Phi n पहले बड़ा था पावर से, तो यूज नहीं कर पा रहे थे. तो तुम अगर डिवाइजर को ब्रेक कर लिए तो phi n तुम्हारा रेंज में आ जाएगा एंड यू कैन सॉल्व. दैट्स द लॉजिक ऑफ चाइनीज रिमाइंडर थ्योरम. So that is why n को I'll split it as a into b, divide it by a first, the total number को, and then divide it by b and calculate the individual remainders, and then this is your final answer, a r2x plus b r1y. अभी जैसे लगेगा थोड़ा याद रख लो, बट ट्राई एंड अंडरस्टैंड द लॉजिक फर्स्ट एंड धीरे धीरे विथ प्रैक्टिस यू विल गेट देयर. So that question 3 to the power 52, let us see how it can be solved. So step 1, we'll go ekdam stepwise. Step 1, my divisor n here is 77, so I'll break it as 7 into 11. So I get a as 7 and b as 11, and you can say that 7 and 11 are co-prime to each other also. They have nothing in common except 1. So a is 7 and b is 11. Then step 2, you find the remainder when 3 to the power 52 is divided by 7. तो ये जब 7 आ रहा है, मैं क्या करूंगा, इसको ऐसे ब्रेक करूंगा, 3 to the power 48 into 3 to the power 4 divided by 7. Why did I break it as 3 to the power 48? Fermat's theorem, 7 is a prime number. तो पावर या तो 6 या एनी मल्टीपल ऑफ 6 रहेगा, तो रिमाइंडर 1. एंड 3 to the power 4 is 81. 3 to the power 4 is 81. 81 divided by 7, रिमाइंडर is 4. तो तुम्हारा यहाँ पे आंसर आता है 4, which is your R1. I got the value of R1. Then step 3, I'll have to find the remainder of 3 to the power 52 when divided by 11. So I'll break it as 3 to the power 50 into 3 to the power 2. ये छोटे छोटे क्वेश्चन हमने ऑलरेडी सॉल्व किए हुए हैं फॉर्मेट्स थ्योरम में. डू वॉच दैट, यू विल अंडरस्टैंड व्हाट आई एम ट्राइंग टू से हियर. एंड ये कैसे सॉल्व हो रहा है, बहुत ही इजी चीज है फॉर्मेट्स थ्योरम. तो 3 to the power 50 and 3 to the power 2, अगेन बिकॉज यू हैव 11 हियर, तो पावर या तो 10 या एनी मल्टीपल ऑफ 10 रहेगा, तो रिमाइंडर 1 आएगा. तो यहाँ पे रिमाइंडर 1, whereas here the remainder is 9. So 1 into 9, I got the value of R2 as well. This is R2. Then step 4, we have to figure out ax plus by is equal to 1. This implies I'll have to figure out 7x plus 11y is equal to 1. ये इक्वेशन से x and y को मेरे को इंटीजर रख के ही सॉल्व करना है. तो देयर कैन बी मल्टीपल आंसर्स टू दिस, एंड ये बाय ऑब्जर्वेशन ही करना है, इसको बाय ऑब्जर्वेशन, बिकॉज कोएफिशिएंट्स विल एवरी टाइम बी डिफरेंट. तो बाय ऑब्जर्वेशन, तो मेरे को ऐसा एक मल्टीपल ऑफ 7 ढूंढना है एंड एक मल्टीपल ऑफ 11 ढूंढना है जहां पे दे आर कंसेक्यूटिव. नाउ देयर कैन बी मल्टीपल आंसर्स टू दिस. फॉर एग्जांपल कैसे देखो, मैं x को -3 एंड y को 2 ले सकता हूँ. तो -21 plus 22. I can take x as 8 and y as -5. So 56 minus 55. I can take x as -14 and y as 9. तो -98 plus 99. तो कोई भी आंसर हो सकता है इसमें. You take any value. आराम से आंसर ऑल केसेस में आएगा, एवरीथिंग इज करेक्ट। बट अगर आंसर ऑल केसेस में आएगा ही, why not take the smaller values, because that will help you calculate faster. So from this I can conclude, okay, x is -3 and y is 2. Now you got everything. A r2x, b r1y, all the values I got. So step 5, the final remainder is a r2x plus b r1y. So a is 7 into r2 is 9 into x is -3 plus b is 11 into r1 is 4 and y is 2. So is 63, ये -189 plus 88. So -189 plus 88 is -101. This is your negative remainder. How to make it positive? Now you add the divisor twice, 77 plus 77. So answer is 53. To make a negative remainder positive, keep adding the divisor until it has become positive. So I got a value, -101 is my remainder, but that's written in the negative form. We don't conventionally write remainders in the negative form, so you keep adding the divisor. So 77 एक बार add किया, फिर भी positive नहीं हुआ, add it again. So 53. That is our answer. Make sense? Let me check calculation सही है नहीं. 101 आ गया यहाँ पे, तो दो बार 77, 154 and 101 to 53. A little lengthy because ऐसा step wise करना पड़ता है, R1, R2, X and Y, A and B, and then you have to combine. तो थोड़ा time लगेगा and you need practice for this. But then you can solve any question using this reminders, Chinese remainder theorem use करके कोई भी question solve कर सकते. And this is one side of looking at it, Chinese remainder theorem. One way of looking at it. I'll tell you another aspect, basically another design of questions. वहाँ पे भी Chinese remainder use होगा, but in a little different way. So let's solve one more question like this so that you get comfortable with the idea of how to apply these questions. Let's say second question देखते हैं यहाँ पे. Again we'll go stepwise. First step 1, n is equal to 120. How will I break it? I'll break it as 8 into 15 such that they are co-prime to each other. 8 into 15. So this is A and this is B. 8 and 15 are co-prime. तुम 3 and 40 भी ले सकते हो, वो भी co-prime है, but take closer numbers so that ज़्यादा बड़ा calculation करना ना पड़े. Step 2, find the remainder of 17 to the power 26 when divided by 8. Now 17 divided by 8 remainder is 1, so 1 to the power 26, ये तो remainder 1 आ गया, and let us say this is R1. We don't need any theorem here. 17 divided by 8 remainder 1, so 1 to the power 26 remainder 1. But when I divide this, 17 to the power 26 when divided by 15, so 17 divided by 15 remainder is 2, so 2 to the power 26 divided by 15. What I'll do is I'll write it as 2 to the power 4 to the power 6 into 2 to the power 2 divided by 15. अब तुम सोचोगे ऐसा क्यों लिखा? Because 2 to the power 4 कितना होता है? 16. And when 16 is divided by 15, remainder is 1. So 1 to the power 6 तो remainder 1 ही आएगा, and 4 divided by 15 remainder 4. So overall you get 4. This is R2. तो यहाँ पे मैंने कुछ थ्योरम यूज नहीं किया. I just reached a multiple using that power. Such that divide करने पे +1 या -1 में अगर रिमाइंडर रह रहा है, why to go for theorem? And if you want to use theorem, because 15 है, you can go for Euler-Stoichern method and then calculate. सेम ही आंसर आएगा. अगर इसको Euler-Stoichern में भी करना चाहो तो कर सकते हैं. जैसे 15 है 3 into 5, so you can calculate 5 of 15. So 15 1 minus 1 by 3, 1 minus 1 by 5, so you get 8. So 17 to the power 26 divided by 15. From 17 to the power 8, 17 to the power 8, 17 to the power 8 into 17 divided by 15 कर सकते. So in each case the remainder is 1. यहाँ पर remainder 2 2, तो overall आ रहा है 4. Same process, but यहाँ पे मैं बिना theorem का भी कर लिया इसको solve. Hope this is making sense. A little advanced. Those of you would be watching this for the first time, I'll sincerely suggest to start from the beginning. Basic remainder theorem से देखो, तो ये जो यहाँ पे हम ब्रेक कर रहे हैं, you will be able to relate. नहीं तो थोड़ा डिफिकल्ट लगेगा कि क्या कर रहा है ये. ठीक है, तो watch it from the beginning, you will definitely understand. Now I got R1, I got R2, I know A and B. I just need to figure out X and Y now. So I'll write 8X plus 15Y is equal to 1. तो यहाँ पे मैं X को 2 and Y को -1 ले सकता हूँ. So 16 minus 15. So my final remainder R is A R2X plus B R1Y. So A is 8, R2 is 4 and X is 2 plus B is 15, R1 is 1 and Y is -1. 8 into 4, 32 into 2, 64 minus 15. So 64 minus 15, I get 49 and that is my answer. पूरा simple steps में you will get the answer and will finally reach here. A R2X B R1Y. तो 6 components A B question से मिल जाएगा. R1 R2 तुम individually A B को divide करके मिल जाएगा and then X and Y you will have to calculate observation. And then A R2X B R1Y. You will get the answer very conveniently. So hope these two examples gave you an idea how Chinese remainder theorem is used. You can take questions जो questions हमने Euler's में किए थे, try them using Chinese as well कि हो रहा है नहीं हो रहा है. You will understand that how this is used, and once you get to understand this, then the choice is yours in the exam. Should I go for a theorem or not? जैसे मैंने यहाँ पे दिखा है, मैं बिना theorem के भी कर सकता हूँ, but not always this can be done. Sometimes it can be done, sometimes we have to use the theorem. So it depends on the question. क्वेश्चन में अगर नेसेसिटी है तो कर लेंगे, नहीं है तो नहीं करेंगे. बट फॉर दैट वी नीड टू नो द थ्योरम, ऑल्सो वी नीड टू नो हाउ द थ्योरम इज यूज्ड. ओनली देन वी कैन डिसाइड कैन दिस बी यूज्ड एंड वेदर दिस शुड बी यूज्ड. तभी जाके विल रीच दैट स्टेट. ठीक है. सो वी नीड टू प्रैक्टिस मोर एंड मोर ऑन दिस टू गेट मोर कंफर्टेबल विथ स्पीड एंड कैलकुलेशंस. नाउ लेट्स लुक एट अनदर एस्पेक्ट ऑफ चाइनीज रिमाइंडर थ्योरम. बहुत ही छोटा सा सिंपल सा क्वेश्चन ले रहा हूं. जैसे यहाँ पे बोला फाइंड द स्मॉलेस्ट नंबर विच व्हेन डिवाइडेड बाय 5 and 8 leaves a remainder of 2 and 3 respectively. Also find how many such 2-digit numbers are possible. So what I'll do is I'll take let the number. Okay. Let the number be n. ठीक है. तो n का यहाँ पे दो प्रॉपर्टी दिया है बेसिकली. क्या बोल रहा है? That this number n when you divide it by 5, यहाँ पे मैं डिवाइजर लिखता हूँ. When I divide this by 5, the remainder is 2, and when I divide it by 8, the remainder is 3. ठीक है. 5 में डिवाइड करोगे 2 आ रहा रिमाइंडर, 8 में डिवाइड करोगे 3 आ रहा रिमाइंडर. तो ऐसा क्या नंबर हो सकता है? तो व्हाट यू डू इज स्टेप 1, I can basically say that the numbers you are trying to calculate here, they have two properties. First property, when you divide by 5, remainder is 2. Second is divide by 8, remainder is 3. What you do is you take one property at a time and start with the highest divisor. Start with the highest divisor. तुम 5 से भी स्टार्ट कर सकते हो, आंसर सेम ही आएगा. बट इफ यू स्टार्ट विद द हाईएस्ट डिवाइजर द कैलकुलेशंस विल बी मिनिमम. दैट द नंबर n व्हेन डिवाइडेड बाय 8 द रिमाइंडर इज 3. तो ऐसे क्या क्या नंबर्स होते हैं? व्हाट आर द नंबर्स व्हिच व्हेन डिवाइडेड बाय 8 विल लीव अ रिमाइंडर 3? तो लिखते हैं पहला नंबर तो 3 है. तो बेसिकली आई कैन राइट n as 8k plus 3. 3 more than a multiple of 8. So when you divide them by 8 the remainder will be 3. क्या क्या नंबर्स हो सकते हैं? पहला नंबर है 3. When you put k as 0, k को यहाँ पे 1 पुट करो you will get 11. k को 2 पुट करो 19. k को 3 पुट करो 27. Then 35. Then 43. Then 51. Then 59 and so on till infinity. There are infinite numbers which when divided by 8 will leave remainder 3. Now our number n जो हम calculate कर रहे हैं, it is one of these numbers. We don't know which one, but it is one of these numbers. तो step 2 में क्या करना है? From the numbers that you calculated in step 1, by observation calculate the first number. Only we need the first number. उसके बाद pattern आ जाएगा. Which number in step 1 when divided by 5 leaves a remainder 2? So it's not 3, not 11, not 19, but 27. This is the first number. Divided by 5, it leaves a remainder 2. And all you need is the first number. मैं ऐसा बैठ के पूरा चेक नहीं करना, बस पहला नंबर चाहिए 27. The second number will come after a gap of the LCM of divisors. मेरा divisors का LCM कितना है? 5 and 8 है divisors. तो LCM है 40. तो 27 में 40 गैप के बाद मेरा नेक्स्ट नंबर आएगा 67. देन आएगा 107, देन आएगा 147, 187, 227 and so on till infinity. All these numbers here belong to this category n, which when divided by 5 they leave remainder 2, which when divided by 8 they leave remainder 3. All the numbers here. So there is not one single number. इसीलिए क्वेश्चन का डिजाइन देखो, पूछ रहा है फाइंड द स्मॉलेस्ट नंबर. Hence our answer will be how much? 27. 27 is the smallest number. Find the smallest number, वो 27 है. And how many such 2-digit numbers are possible? 2 ही 2-digit number हो सकते हैं, 27 and 67. Only 2 2-digit numbers. Understand the pattern. This is very important. Once you get the first number, the subsequent numbers will come at a constant difference. What is the difference? LCM of the divisors. 5 and 8 मेरे divisors है, उनका LCM का gap में वो आता रहेगा 40 40 40 40. And all these numbers तुम check करो. 67 को 5 में divide करेंगे, remainder 2. 8 में divide करेंगे, remainder 3. 107 again same thing. 147 again same thing. Every time you keep getting the same result. Okay, this is yet another way of looking at Chinese remainder theorem. So you take one divisor, one remainder at a time, and then keep filtering out depending on the properties. ठीक है, काफी सिंपल क्वेश्चन है. एंड इसमें फिर भी मैंने 2 डिवाइजर लिए. इसको थोड़ा और लेंथी कर सकते हैं बाय टेकिंग 3 डिवाइजर्स. कैसे? लुक एट दिस सिमिलर डिजाइन. अगेन लेते हैं, लेट द नंबर बी n. ये तुम पॉज करके खुद कैलकुलेट कर सकते हो. लेट द नंबर बी n एंड देन चेक द एक्सप्लेनेशन. Now n has got 3 properties here. When divided by 3, 4 and 7, the remainders are 1, 2 and 3 respectively. ये तुम्हारे divisors हो गए and ये तुम्हारे remainders हो गए. We'll start with the highest divisor. That n when divided by 7, the remainder should be 3. Step 1, n should be of the form 7k plus 3. तो 7k plus 3 में क्या क्या नंबर्स हो सकते हैं? 3, k को 0 पुट करे तो k1 पुट किया 10, then 17, then 24, then 31, then 38, then 45 and so on till infinity. All these numbers when divided by 7 they will leave a remainder 3. What is step 2? Step 2 में तुम चेक करो when divided by 4 remainder 2 कहाँ पे आ रहा है? तो 3 में तो नहीं हो रहा है, 10 में हो रहा है. You need the first number. And the second number will come after a gap of the 2 LCM that you have considered. मैंने 7 and 4 ये 2 डिवाइजर कंसिडर किया है, इनका LCM. 3 अभी तक पिक्चर में आया नहीं है. तो 28, तो 28 plus 10, next number is 38, जो देखो यहाँ पे है. Then next number after gap of 28, तो 66 आएगा. Then 28, 66, 20, 86 and 8, 94. Then 28 plus 8 किया तो 102, 20, 122 and so on till infinity. All these numbers in step 2 when divided by 4 leave remainder 2, also when divided by 7 leave remainder 3. And for this particular question, because there are 3 divisors, हम और एक step आगे जाएंगे. Step 3, the numbers that we got in step 2, उसमें which numbers when divided by 3 will leave remainder 1. And all we need is the first number. Divided by 3 remainder 1 कहाँ पे आ रहा है? 10 में ही हो रहा है, तो 10 आ गया. And the next number will come after a gap of LCM of all the 3 divisors, 3, 4 and 7. Because by the time you have reached step 3, all the divisors have been considered. तो उनका तीनों का LCM 84. तो 10 and 84 में 94, देखो ये नंबर है. देख रहे हो कैसे स्टेप वाइज फिल्टर हो रहा है. तुम जो भी स्टेप में होगे उसी स्टेप तक जितने डिवाइजर्स लिए हो उनका एलसीएम लेना है. बाय द टाइम यू रीच द लास्ट स्टेप, यू हैव कंसीडर्ड ऑल द डिवाइजर्स, तो यू टेक ऑल उनका एलसीएम. 94, 94 and 84, 178 and so on. All the numbers that I got in step 3, all these numbers when divided by 3, 4 and 7, they leave remainder 1, 2 and 3 respectively. ठीक है, तो उसमें स्मॉलेस्ट नंबर तो 10 आ जाएगा आंसर. But also it is saying find how many such 3-digit numbers are possible. Now we can put a pattern to the like values that I got in n. तो यहाँ पे मैं दिखाता हूँ. देखो n आ रहा है 10, then 94, then 178, ठीक है, 178, 170, 80, 250, 266 एंड सो ऑन। तो यहाँ पे बेसिकली 84 ऐड होता रहा है। Every subsequent number you keep adding, like you keep adding 84. So I can generally write n is of the form 84k plus 10. 84k plus 10. This is my general value of n. तुम इसमें k का जो वैल्यूज पुट करते जाओगे तुम्हारा n का उसी हिसाब से वैल्यू आएगा। k is equal to 0, you get the smallest number n equal to 10. k equal to 1, you get n is equal to 94 and so on. Question is saying ऐसे कितने 3 digit numbers possible है? तो फॉर 3 digit numbers पहले लिखते हैं लास्ट 3 digit नंबर। लार्जेस्ट 3 digit नंबर कौन सा है? 999. बट इज इट इन दिस फॉर्म? नो। तो 999 को पहले 84 से डिवाइड कर लो, देखो क्या रिजल्ट आता है। 84 1 जा 84, 159, अगेन 84 1 जा 84, 9 minus 4 is 5, 15 minus 8, 75 आ गया। तो आई सॉ दैट लार्जेस्ट नंबर इट इज 84 into 11 plus 75। मुझे चाहिए 84 into 11 plus 10, 84k plus 10 के फॉर्म में चाहिए। तो तुम यहाँ से 60 माइनस कर लो 65, तो 75 माइनस 65 10 हो गया। इसको वही रखो 84 into 11, तो 999 से भी 65 माइनस कर लो, तो 9 9 minus 6 3, 9 minus 5 4। तो 934 इज द लार्जेस्ट 3 डिजिट नंबर जो कि इस फॉर्म में है, k इक्वल 84k plus 10। मुझे लार्जेस्ट 3 डिजिट नंबर नहीं लेना है क्योंकि वो तो 999 है। आई हैव टू टेक द लार्जेस्ट 3 डिजिट नंबर विच इज इन द फॉर्म 84k plus 10। अब 84k plus 10 में कौन सा नंबर आ रहा है, कैसे निकालेंगे? तो पहले मैं 999 जो कि सबसे बड़ा नंबर है उसको मैंने 84 में डिवाइड किया, देखा रिमाइंडर आ रहा है 75। बट मैं देख रहा हूँ मुझे 84k plus 10 के फॉर्म में चाहिए, 75 नहीं चाहिए। तो जितना एक्स्ट्रा है माइनस कर लो, तो मैंने माइनस 65 RHS में किया एंड LHS में भी कर लिया। तो 934 इज द लार्जेस्ट 3 डिजिट नंबर। व्हाट इज द स्मॉलेस्ट 3 डिजिट नंबर? स्मॉलेस्ट 3 डिजिट नंबर के लिए k को 2 पुट करो, n आ रहा है 178। तो फ्रॉम k इज इक्वल टू 2 which is 84 into 2 plus 10, 178, till k is equal to 11, 84 into 11 plus 10, I get 934। कितने नंबर्स रहेंगे 2 से लेके 11 तक? हाउ मेनी सच 3 डिजिट नंबर्स? 2 से लेके जब 11 तक कैलकुलेट करोगे, फ्रॉम k is equal to 2 till 11, we will have 10 numbers, 2 3 4 5 6 7 8 9 10 11, 10 values of k। so 10 possible 3 digit numbers which will satisfy this property। इसको हम LCM model 3 भी बोलते हैं, where you have multiple divisors and multiple remainders। how do you get the number? we have multiple divisors 3 4 and 7 and multiple remainders 1 2 and 3। तो इसको इसी वे में सॉल्व करते हैं। प्रोसेस काफी सिंपल है, थोड़ा टाइम लगता है। क्या करना है, ऑलवेज स्टार्ट विद द हाईएस्ट डिवाइजर एंड रिमाइंडर एंड देन ग्रेजुअली फिल्टर इट आउट। फिल्टर करते टाइम उसका प्रीवियस स्टेप में जो नंबर आया होगा उसमें से बाय ऑब्जर्वेशन गेट द फर्स्ट नंबर ओनली, एंड वो मिल ही जाता है। डोंट थिंक दैट ऐसा मिलेगा नहीं, आराम से मिल जाएगा। एंड वंस यू गेट द फर्स्ट नंबर, subsequent numbers will come at a gap of LCM of the divisors already considered। जैसे जब स्टेप 2 में हो गए तो स्टेप 1 एंड 2 में जो डिवाइजर्स लिए होंगे उसका एलसीएम, स्टेप 3 में आ गए तो स्टेप 1 2 एंड 3 सारे डिवाइजर्स का एलसीएम। मान लो ये क्वेश्चन 4 डिवाइजर्स का होता, अकॉर्डिंगली यू वुड हैव लाइक प्रोसीडेड अकॉर्डिंगली। Process, so I hope all of you understand now। So this is Chinese remainder theorem। I'm not saying always you do get questions from this, but as CAD aspirants and if we are aiming for a high percentile, you should know every minute nuances of every topic, okay? So that will give you more confidence in the exam, and if you know a sure shot method of solving it, you have practiced properly and दिख रहा है that इसको मैं 1-1.5 मिनट में कर ही सकता हूँ, so why not solve that? Why not solve that? And we need that kind of clarity of thought in the exam that will help us score higher। ठीक है? Hope all of you got an idea about what Chinese remainder theorem is। Please sincerely watch the previous videos from the beginning, basic remainder theorem से। I can assure that remainders का any question end to end you'll be able to answer very easily। So that is it from my end for this session। Hope you guys like the session, and if you have watched it so far, do subscribe to the Aptitude Club channel। It's a new channel, but I try and upload videos regularly, and every day you can get some content related to your CAT preparation, and it will help you immensely in your journey। So like the video, share it with your friends who are also preparing for CAT, and do subscribe the channel, hit the bell icon if you haven't yet. We'll meet again very soon in yet another video. Till then, have a nice day everyone. See you. Bye bye.